Hello, welcome to this tutorial. This is going to be our first tutorial. I hope you guys will find it useful. My name is Amit from Kritrim Vault. This tutorial is regarding 3D printing modeling techniques. In this tutorial, I will tell some key steps that you have to keep in mind while creating any 3D printable model. So let's get started with lesson 1. So we are going to discuss about material guidelines first. It is very important part of 3D printing. It's related to our material. There are so many different varieties of material available like gold, silver, platinum, brass, bronze, plastic, flexible plastic, frosted plastic, etc. etc. Every material have some special requirements regarding modeling. So we have to decide first that in which material we are going to take our model print. Once you have decided the material, then you have to follow all designs rule like minimum wall thickness, detail level and clearance threshold. Because to get a perfect print, we need to take care of these things. Okay, the question is where do we get all these material guidelines? So don't worry about it. There are so many online 3D printing services available. They have mentioned all material guidelines in the detail. Our second point would be minimum and maximum product size. Basically, it's related to size of our model. There are so many different printing machines are available in the market and every machine has few limitations like we can't create a very tiny model and a very large size model. So that is why we have to keep in mind that of which size we are going to take our print and what kind of printing machine service we are using and what its limitations. These are very important. The third point is avoid non-manifold geometry. First of all, what exactly a non-manifold geometry means? We are facing this error because of these following situations shown in the images. Non-manifold geometry is one of the main problems when our boolean does not work. We face problems in renderings as well. So get rid of this error because if we won't, then our model will be rejected by the printer. The fourth point, clean boolean. We are using boolean so many times. There are few situations in which when we apply a boolean, then the boolean leaves some geometry behind. We have to clean that unwanted geometry. So keep in mind that must check your geometry after hitting boolean. The fifth point, no interpenetrated and overlapped mesh. Actually, we mostly find this situation when we have a very detailed object that created with so many small and large pieces and they are very close to each other. In that case, if our mesh intersecting and overlapping itself, then we will face problems with printing. So our mesh has to be complete single element in which every piece of geometry is properly joined. Our sixth point is minimum clearances threshold. It means clearances between parts. We are facing this issue in case of moving mechanical parts or anything similar. We have to maintain an appropriate clearances threshold value between different parts. In case if we don't, then different parts get fused. As you know that now every material might have different minimum requirements. So go through your material design rules to get an exact value. You can decide a value according to your model complexity. Sometimes we have to go through some trials to get a perfect value. I am giving you a minimum value of 0.5 mm to 1 mm. In most cases, this value works very accurately. The seventh point, minimum wall thickness. Wall thickness is very important part. If our model has zero thickness, then we cannot print it. This is the biggest reason why a printer rejects a model time and again. First of all, we have to understand what is minimum wall thickness. Actually, it's the thickness value of the thinnest part of your model. Each material has some specific requirements according to that. Thin part of the model will have that mentioned thickness value to get a good print. This value is different in case of each material. 2 mm thickness is best in many cases. We can use wall thickness of 0.8 mm also, mostly in cases of more flexible walls. The 8th point, mesh normals. If the model have inverted normals, then 3D printer will not detect that surface because the normal of the mesh are facing inwards. Must check your model normals should be facing all outwards to get a perfect print. 9th point, 3D files format and size. As we know that different printing machines has different limitations. There are only few file formats which can be read by printer. Files format like .stl, .obj, .dae, .x3d, .vrml, .collada, etc. And there is a limitation regarding file size. Some printer only read a file size of 100 MB or 64 MB or less. So you have to find out which file format or size your printing machine supports. Listen to me carefully. Here are a few notes which needs to be taken care before starting any 3D printing work. Must choose a right printing service and go through all of its possibilities and limitations, because choosing a right service gives you better handling and results. Second, there are so many online solidity check tools available which may highlight any problem in your model like wall thickness, holes, non-manifold, geometry, normals and your product size. So in some case you can fix them online, but in worst case you have to fix those error inside your 3D package. Let's discuss about what sort of models we can create for 3D printing. We can create solid models, hollow models, enclosed and interlocked models, and the last one, embossed and engraved models. What is solid models? If you want a complete solid model, then you have to make your model completely closed, means watertight. Do not leave any hole. They are stronger than hollow models. They are costly because they are using more material. Hollow models. These kind of objects need an escape hole to create on a model where it cannot be found. You can make an escape hole at the bottom or as you like. Hollow models are cost effective than solid as they are not using that much material like solid models. The third one, enclosed and interlocked models. Like one object inside other but not fused. They are actually working models. It means two parts working together, like a sphere inside a box, and a chain is a good example too. Only in few materials you can print such models. The fourth and the last one, embossed and engraved models. When we are creating such models, we won't get expected depth of the models as created in the 3D software. So if embossing and engraving is very important, then you have to make them as deep as possible. So we're going to discuss about what all 3D packages mostly use for modeling. We use 3dsmax, Maya, ZBrush, Cinema 4D, Blender, etc. One important thing, you can use any of these softwares for creating models, or you can use a combination of these for getting good results. They all are good at modeling but not very accurate and efficient at creating some real world mechanisms like machines, working parts or similar things. For that purpose, you can use AutoCAD and SolidWorks or something like similar. So far, this lesson is a theoretical description of 3D printable modeling techniques. Our first lesson is finished now. Hope you guys found it useful, a bit knowledgeable. Now we move on to lesson 2, in which I am going to explain you all these points practically inside a 3D package. If you will have any questions, you can ask in the comment sections below. Stay tuned with us for more raw material and tutorials from Kritrim Vault. Don't forget to subscribe. Have a nice day. Goodbye.